This is a particle podcast. WA Science told different, powered by Scitech.
Please Look Up is recorded at Scitech on Whadjuk Noongar land. Good evening, everybody, and welcome to Please Look Up, the monthly podcast produced by Particle, where we take you through a guided tour of the night sky as seen from Perth, as well as taking a deep dive into some of the more out-of-this-world space news. In this episode, we will be discussing what you can see in the night sky in the month of November, as well as taking a deep dive into fast radio bursts. My name is Leon, and I'm joined by Sharna, a professional presenter from the Scitech Planetarium. Sharna, thanks for being here.
It's lovely to be here.
All right, so Sharna, we'll start this podcast as we start all of them, and I'm going to ask you, what can a casual observer expect to see in the night sky this month? What planets are out?
So firstly, there is Jupiter, which is the real showstopper in the evenings this month. It's at opposition early in the month, so it is the closest and brightest it will be for the rest of the year. So this month is your best time to get a really good look at Jupiter, which you can find in the east.
Okay, Jupiter, that's I don't want to say the star of the show, but you said the showstopper. You also mentioned opposition. What does opposition mean?
Yeah, so Jupiter is at opposition in relation to the Sun. So it's directly opposite the Sun in the sky.
Oh, I see.
So they're in opposition, so they're facing each other. So this means that Jupiter will rise just as the Sun sets and will be brightly illuminated in our skies.
I see, right. Okay, so like if you point at the Sun with one hand and point at the Sun at Jupiter with the other hand, you're pointing in opposite directions.
Absolutely, yeah,
right,
direct opposites.
Yeah, okay, that's okay. It's an Earth-centered frame of reference. That makes a bit more sense. And if you look at Jupiter in a telescope, what should we expect to see then?
Yeah, looking at Jupiter through a telescope, you should be able to make up the planet and see the belts and zones that make up the distinctive stripes that run across the planet. You may also be able to take a look at some of its moons, so the four largest should be easily visible throughout a telescope.
The Galilean moons.
Absolutely.
So just through a decent little telescope.
Mm-hmm.
Wow, okay, that's good to look forward to. Any other planets that are out?
Absolutely. So there's Saturn in the north at sunset, then moving across to northwest in the later evening. It should look slightly yellowish in our night sky.
Okay, I'll keep an eye out for that.
Yeah, so if you want to keep an eye out for it, the best day to head out would be the 22nd of November. So on that evening, you'd be able to see Saturn, the Moon and Jupiter all evenly spaced across our night sky.
That's a sight to look forward to. The 22nd of November, you said?
Yes.
All right, I'm definitely going to put a note in my calendar to do that. All right, let's keep going. Any other planets?
Yeah, so Venus will be up just before sunrise, but you'd have to be awake quite early to get a glimpse of that at this time of year.
Mm-hmm. I'm not a morning person, but Venus has been up before sunrise for the last couple of months, if I recall correctly. But so yes, if you are a morning person, I guess Venus is out there for you.
And then there's Mercury in the west just after sunset in the second half of the month. So I'd recommend using an app like Stellarium or Sky Safari to know where to look, because it can be a little hard to spot if you don't know exactly what you're looking for.
Right, yeah, Mercury, in my attempts to observe it in the past, has always been a little tricky to...
A little more elusive, definitely.
Yeah, exactly. All right, so, but yeah, like Stellarium or Sky Safari, just like you said. Good to know. What else is happening in November?
Yeah, it's Astrofest time again. So
I love Astrofest.
Yes, it's definitely a fan favourite. So this year, Astrofest will take place on Saturday the 18th of November in the evening. Astrofest is a family event with telescopes set up so you can take a look through, and also presentations and different displays. It's definitely worth checking out if you get a chance.
All right. I have already got that in my calendar, actually. 18th of November in the evening. Can't miss it. Where is that again, just for anybody who doesn't know?
Curtin Uni.
Right.
Yeah.
All right, Astrofest on the 18th of November. Can't miss it. Anything else? It sounds like it's a busy month.
So we've got 2 different meteor showers that you can also check out this month if you get a chance. So we have the southern and northern Taurids meteor showers, and they peak on November 5th and November 12th respectively. So both will appear to come from within Taurus in the northeast.
Oh, okay. So the constellation of Taurus.
Yes, yeah.
Gotcha.
So the best time to view them would be in the mid-evening, and in good conditions you might see about half a dozen meteors per hour.
Okay, that's something to look forward to. So that was November 5 and November 12.
Yes,
okay,
yeah.
Good to know.
And just a little later in the month, there's also the Leonids meteor shower. so on November 18th. So this can be viewed just before sunrise, and in this one you might see about 10 meteors per hour.
Wow. Okay, that's good to know. All right, so that's on the 18th of November, so you can get up before sunrise and see the Leonids meteor shower and I guess Venus as well, and then you can stay up and then go to Astrofest at night.
Absolutely, that is a very big day.
Look at Jupiter and Saturn at Astrofest. All right, that's what I'm doing on the 18th. Any interesting constellations to look for? I know that like November can be a bit of a tough month with like the Milky Way is very low on the horizon, if I remember correctly.
Yeah, you're absolutely right. This month's more interesting constellation would be Grus.
Grus.
Yeah.
I've never heard of that.
So Grus is a Latin name which translates to the crane, as in the bird, rather than the
construction equipment.
Yes. Yeah.
Okay, so it's a bird constellation. All right, so Grus, the crane. What's something interesting about Grus, given that 1 minute ago I'd never even heard of it before?
Yeah, so it's definitely one of the lesser known constellations, but Grus is one of 4 constellations that are part of a group called the Southern Birds. So this includes 4 different constellations. So it includes Pavo, the peacock, Phoenix, obviously a phoenix, and Tucana, a toucan.
Oh, okay. And so they're all other constellations just in the southern sky.
Yeah.
Okay, There we go. The Southern Birds, that makes sense. What else?
Grus is also home to the Spare-tyre nebula.
The Spare-tyre nebula.
Yes,
What in space is the Spare-tyre nebula?
It's a very creative name, but it kind of looks like a tyre, so it's roughly donut-shaped when you have a look at it. So the Spare-tyre nebula is a planetary nebula.
Oh, okay. I was about to say, I know that nebula is like a really broad blanket term, and I also am aware that a planetary nebula actually doesn't have anything to do with planets. What is a planetary nebula?
Yeah, so it's a dying low-mass star. So it's less than 8 solar masses, so less than 8 times the mass of the sun. Mm-hmm. So it throws off its outer layers into space, which then glow from exposure to the core of the star.
Right. So a dying star. So it's got nothing to do with planets.
Not really, no.
Why is it called a planetary nebula then?
Yeah, so a nebula is a bit of a catch-all and possibly even a slight misnomer for this particular item. So astronomers in past centuries didn't always have the best equipment or the best telescopes to make their observations. So anything diffuse, anything fluffy or fuzzy that they found in the night sky, they kind of just called it a nebula.
I see.
Yeah, so some nebulas were round and looked kind of like planets, so they were called planetary nebula. Basically fuzzy planets, even though we now know that they don't really have anything to do with planets at all. Now, astronomers could change the name to something a little bit more fitting, but stars are round and tend to throw off their layers evenly, so many planetary nebula appear roundish like a planet, so the name stuck. But lots of things get called nebula, so it's too broad of a term these days. So some galaxies were once even called a nebula. For example, our neighbouring galaxy, the Andromeda Galaxy, was once called the Andromeda Nebula. But now we know a lot more about what it is.
Right, there we go. I see what you mean. The term nebula, yeah, it is a bit too broad, isn't it? Given
Yeah.
a dying star and a galaxy containing hundreds of billions of very much alive stars
Can
were
fit in
both
the
once,
same category,
called,
yeah.
nebulas.
Yeah.
Okay, but the Spare-tyre, that's such a great name for anything in space.
Brilliant.
All right, I'm going to have to look it up to see if it actually looks as described. All right, so it's a pretty busy month in November with Astrofest and planets and meteor showers and all sorts of interesting things. Let's leave Earth behind for a little bit. Is there any interesting big news in the wide world of space?
Absolutely. So an Australian-led team of scientists used CSIRO's ASCAP telescope to discover the most distant fast radio bursts ever.
Wow, that's a big sentence. A lot of things going on in there. Let's just start nice and simple. Can you tell me, what is a fast radio burst?
Yeah, so a fast radio burst is a millisecond burst of radio waves coming from space.
Yeah, it makes sense. I don't really know what other answer I expected.
So they were actually first detected by the Parkes Radio Telescope in 2001.
Oh, the dish.
The dish, absolutely. But they had not been recognised until 2007. These bursts come from all over the sky, meaning they're extragalactic in origin, so they must be enormously powerful for us to see them here from all across the universe.
Wow, from all over the universe. Can I just pick you up on that? How does the fast radio bursts arriving from all different parts of the sky, how does that mean that they're extragalactic?
Yeah, that's a really good question. So extragalactic means it's coming from outside of our home galaxy, so outside of the Milky Way. So many of us know the Milky Way as this milky, light, cloudy strip that runs across our night sky. Now, if these bursts came from within the Milky Way galaxy, we would expect to see fast radio bursts localised to just this band of our night sky.
Oh, of course.
Yeah, but in reality they aren't. So they're coming from other areas of the sky, which means they are most likely travelling from beyond our galaxy. So their origin is extragalactic.
Okay, that makes perfect sense. And so what causes these fast radio bursts then?
The simple answer is we just don't know yet.
Oh.
But there are many ideas about their origin. So firstly, we know that the time they are visible is extremely short, so the source may be quite small. We also know that they've travelled a huge distance, so that source is quite likely far away from us. Other than that, we really just have a lot of questions, which is quite exciting.
Right, so lots of potential discoveries to be made in this area.
Yeah, most definitely.
And it was detected by ASCAP. Can you just quickly remind us, what is ASCAP?
Yeah, so ASCAP is the Australian SKA Pathfinder. So it's a radio telescope. It's made of an array of 36 dishes, and each are about 12 metres in size.
Oh, right, so they're like miniature versions of the dish.
Exactly, yes. So it's located up in Murchison, which is about 800 k's north of Perth, and this area has a really low population, meaning the area is essentially radio quiet. So there's very little interference with the signals by human activity. So the radio signal received at each disc is added together using a measurement method called interferometry, which might sound a little complex, but basically means that the dishes essentially behave as one single giant telescope.
Yeah, okay. Wow, that's really clever, isn't it? And so what happened when ASCAP detected the burst?
So the burst was detected on June 6th last year. So ASCAP was able to locate where the burst first came from, but it wasn't able to image it in any way. So scientists used the Very Large Telescope to get some optical observations.
The Very Large Telescope, that's a very descriptive name, isn't it?
Such a creative name again. So far we've had the Spare-tyre nebula and the Very Large Telescope.
Good. So what is the Very Large Telescope then?
Yeah, so the Very Large Telescope is a big telescope from Chile, and it's operated by the European Space Agency. It looks at visible light in the visible spectrum, just like our eyes do. The Very Large Telescope found the burst came from a pair of interacting galaxies located 8 billion light years away.
8 billion light years away.
Yes, very, very far away indeed. In fact, it was a new record for the furthest burst detected to date. So it comes from a time when the universe was less than half of its current age.
Wow, and presumably a very different universe than what we're used to today.
Yeah, very different indeed.
Okay, so yeah, I get it. So ASCAP first detected it and figured out what part of the sky it came from, but in order to understand what the origin was, we needed the VLT to actually see that.
Needed different technology to be able to see it, definitely.
Yeah, that it came from these galaxies. Gotcha. And how powerful was the burst then, if we're seeing it from 8 billion light years away?
Very, very powerful indeed. So the burst released as much energy in just 1 millisecond as the sun releases over 30 years.
How do we even get a feel for that? How many light bulbs is that? What does that work out as?
I don't know exactly how many light bulbs, but if we convert it to numbers, it would be 4 billion watts. So that's 4 followed by 5 billions.
I think that's probably made it even more confusing.
It's a ridiculous number, isn't it?
That's unbelievable. But yeah, no wonder you can see it from halfway across the universe. So why are fast radio bursts interesting, apart from just being really, really powerful?
Yeah, so at this stage, they're interesting just because we don't yet understand them. So they're unknown and we're a little curious about them. If there's something to be understood, it can be a little infuriating not to understand things, but that's pretty much at the heart of science.
It is, isn't it?
Yeah, so there's a puzzle to be solved. But also, fast radio bursts are interesting as they've been shown to be amazing probes of the intergalactic medium.
The intergalactic medium, what is that?
Yes, so the intergalactic medium is a name given to the matter that lives between galaxies. So it's the hot gas and plasma that lives between those galaxies, and it's so hot that it can reach millions of degrees. So by looking at fast radio bursts in detail, we can figure out how much matter there actually is between these galaxies, this intergalactic medium that they've passed through. So we can use fast radio bursts to figure out how much matter is there. And this just might help astronomers to weigh the universe, to figure out how much matter's actually out there.
That's ambitious. And, well, cut to the chase. How much is there? How much matter is in the intergalactic medium?
I can't give you a number as such, but about half the mass of the universe is thought to be in this intergalactic medium.
Half the mass. Does this include dark matter and dark energy?
No. So dark matter and dark energy add up to about 95% of the matter and energy in the universe.
Right.
But what we're talking about here is the other 5%. So we're saying that half of the 5% is stars, planets and galaxies,
Okay.
and the other half is the intergalactic medium.
Right, I got you. Wow, that's still pretty impressive. And it also goes to show that if you say, imagine the universe right now, most people, they will think of stars and planets and galaxies.
Yeah.
That's, what's that, 2.5% of the universe?
Such a small percentage, yeah.
But yeah, another 2.5 is this tenuous hot gas between galaxies.
Yeah, that we don't really know all that much about.
Yeah, and then we know even less about dark matter and dark energy.
Yes, yeah.
So that's the answer. But how are fast radio bursts probes of the intergalactic medium? How do you actually use them to study it?
Yeah, so intergalactic medium is made of plasma. So light from fast radio bursts slows down whenever it passes through this plasma of the intergalactic medium. Since they're extragalactic from really, really far away, they pass through a lot of plasma on their way to us, so they see or interact with a lot of the intergalactic medium.
I mean, that makes sense, yeah. The further away they are, there's more stuff in between us and them. And if they're coming from billions of light years away. Okay, and I feel like this is going somewhere. How is this useful as they pass through the plasma, and how are we able to squeeze information out of that?
Yeah, so this is useful as the slowing down of fast radio bursts is uneven, so it's not happening at a consistent rate across all areas. So fast radio bursts contain a lot of different frequencies, a little bit like a radio broadcasting station giving off different channels.
All right, that's a useful sort of visual thing for me to think of.
Yeah.
Thinking of this bunch of radio waves, all of, you've got your different radio stations. I'm just going through all my favourites in my head there. So they're all sort of bundled together as they travel across the universe.
Yeah, so they're all released at the same time as this little bundle. Then they interact with the intergalactic medium. They are affected a little differently though. So low frequencies get slowed down and affected a lot more than the high frequencies. So the signal is essentially stretched out.
Yeah.
By timing how long the fast radio burst lasts, scientists can kind of work backwards to figure out how stretched out the fast radio burst was, and thus how much intergalactic medium it passed through to cause that amount of stretching.
Right.
So once you know this, you can figure out how much matter is in the intergalactic medium, so you can weigh the universe.
That is so clever. So essentially, at the end of the day, you measure the time, the duration of the fast radio burst, and because it's been stretched out over space, that stretching, in other words, the time of the burst is related to how much matter it passed through.
Perfect, you got it.
Wow, that's really clever. Okay, and you said you use that to weigh the universe. That's so clever, using a time measurement to work out and to weigh the universe. So how much does the universe weigh then?
Well, maybe that's not exactly the right question. I can't give you an answer that ends in kilograms necessarily, but what this gives us is a ratio instead. So we know that half of the universe is in the intergalactic medium. So this was predicted by computer simulations and cosmological models, but it was very hard to measure until we discovered fast radio bursts. So this was first figured out by Australian scientists in 2020. So this latest and most distant fast radio burst is consistent with half the universe being in the intergalactic medium.
Right. Okay, I see what you mean. That the ratio we get is essentially 1-to-1 for everything inside a galaxy. There's the same amount of matter in the intergalactic medium. That's why it's half and half.
Yeah.
Yeah, gotcha. Ignoring dark matter and dark energy.
Of course.
Yeah. Wow. Okay, so yeah, they really are these distant extragalactic probes. That's such a clever application of them. Well, I think that's definitely put a bright light on our day today. I think that's a good place to call it as well. Thank you so much for being here today, Sharna. I've really learnt a lot out of that.
Thank you, Leon.
That's it for this episode of Particles. Please look up. We'll see you next month where we talk about the night sky and the space news for December. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.